Example 9. An advertisement makes the following claim. If you use hair grow and apply it daily, then you will not go bald. Part A. Construct a truth table for the claim. Part B. Suppose you use hair grow, forget to apply it every day, and you go bald. Under these conditions, is the claim in the advertisement false? Alright, so we're going to first construct a truth table, and before we do that, we're going to write out our simple statement. So we're going to let P represent you use hair grow. Q, you apply it daily. And then we have R, you will go bald. Alright, so in this us completing this, we're going to construct a truth table with 8 cases because we have P, Q, and R. 3 simple statements. So let's go ahead and write this out. P, Q, and R. Okay. And before we even do that, let's write out what we're going to identify in the truth table. So it says, if you use hair grow and apply it daily. So we have P and Q. We have a comma before the then, so we're going to place parentheses around P and Q. Then, our connective here, you will not go bald. So we would say not R. So now let's use the truth table. So for P, we have 4 T's and 4 F's. For Q, 2 T's, 2 F's, both times. And for R, we're going to alternate. Alright, so we have here, let's start off, we have parentheses first, P and R. So remember for and, for both statements must be true. Both P and Q must be true for the whole situation to be true. So we have here, for P and Q, we have T and then T for the first 2. And the remaining, they're all false. Then, let's look at not R. We're going to negate. So taking the opposite. So it's false, true each time. And then let's write and finish our statement here. If P and Q, then not R. And remember, our conditional statement says that the antecedent is true and the consequence is false, then the whole thing is false. So as we look at this, our first, looking at P and Q and not R, we have a T for P and Q, and not R we have false, so it makes this statement false. So the rest of the statements here are true. Okay, so we've completed the truth table. If you use hair growth and apply it daily, then you will go ball. All right? So now it says, example B, suppose you use hair growth, forget to apply it every day, and you go bald. Under these conditions, is the claim in the advertisement false? You use hair growth, said that was true, and it says forget to apply it every day, then you go bald. Okay, so T and F we said was false. And what would we say here? Okay. So is this, we have if F then T, and remember when we're talking about a conditional statement, the antecedent it has to be true and the consequence is false, therefore it would make the whole statement false. But this statement here is true. When we finish, therefore, we would say no. Is the claim in the advertisement false? No. Example 10, it says construct a truth table, P or Q, okay, if and only if, not P. If not P, then Q, to determine whether the statement is a tautology. Okay? So just as a reminder, a biconditional is true only when the component statements have the same truth value, meaning both P and Q can be true, it makes it true, both P and Q can be false, and it makes it false. So here we go. We're looking at P and Q. So we're going to construct a table for 4 cases. True, true, false, false, and true, false, true, false. So let's look at the first parenthesis, P or Q. When we have an or, both P, at least one must be true out of P and Q, and the whole statement is true. Therefore, we have T, 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 and F. Then, we're going to look at the second parenthesis, but we're going to look at each variable, each simple statement where we have not P. So that would be false, false, true, true. And we have Q. I'm going to write Q again so we can just write it in order as we read our table from left to right. Now, let's look at not P. If not P, then Q. So remember, for the statement to be false, this means implies that the antecedent must be true, the consequence must be false, therefore it is false. So the remaining P and Q, not P and Q, not P implies Q, we have the first three that are true, the last one being false. Now let's put all of this together. P or Q, we have if and only if, not P, if not P, then Q. Alright, so we're going to be looking at these two columns here that I have an arrow. Remember, it says a biconditional is true only when the component statements have the same truth value. And it says here we're going to determine if this is a tautology, and it means all values are true. And we notice we have both component statements are the same, so we have a tautology here.